All right, a proportional relationship can clearly be seen in a table and on a graph. So in a table, if one quantity is multiplied by an amount, the corresponding quantity is multiplied by the same amount. So an example of that would be 3 times 2 is 6, and then 7 times 2 is 14. Or 3 times 4 is 12, and 7 times 4 is 28. On a graph, a proportional relationship is linear, and it goes through the origin. So it creates a line, and it goes through 0, 0. So this is an example of a proportional relationship because it's linear, it goes through the origin, and in the table, we're multiplying by the same quantities. A non-proportional relationship is right here. So for example, it's linear, but if we multiply, we're not multiplying by the same quantity. So like 2 times 2 is 4, but 7 times 2 is not 9. So it doesn't work. It's not proportional. Decide whether each of the following situations represent a proportional relationship and explain why or why not. So Kareem is ordering video games. Each game costs $3.99.99 or $39.99, and there is a $4.85 shipping charge per order. How much will it cost him to order any number of video games? So if we set up a table, if we have video games here, and the cost that he's going to pay. So for one video game, he would pay $39.99 plus $4.85. So we need to, let's see, I'm going to do that on my calculator. Well, $39.99 is basically 40 plus $4.85. So it's $44.85, but then I'm going to take away the 1 cent that I added here. So it would be $44.84 for one video game. 2 video games would be, I just add $39.99 because we already paid the shipping cost right there. So it would be $44.84 plus $39.99. It would be $84.83. 3 video games, I have to add $39.99 again for the next game. Again, we already paid the shipping charge. So that's $124.82. So let's see if this is proportional, if it fits the table. So to go from 1 to 3, I multiply by 3. So that means that here, to go from the cost here, I would need to multiply by 3. 44.84 times 3 is 134.52, not 124.82. So this is not proportional because multiplying the games by 3 does not also multiply the cost by 3. Miss Peters can grade 20 tests in 1 hour. How many tests can she grade for different amounts of hours? So let's see, if we have hours and tests, 1 hour is 20 tests, so 2 hours would be 40 tests. 3 hours would be 60 tests. Let's see, I'll do 5 hours would be 100 tests. So let's see, 1 times 5 gives me 5. 20 times 5 is 100. And then does this one go through the origin? If I grade for 0 hours, I will grade 0 tests. So yes, it goes through the origin, and it creates a straight line, since each time here we're going up by 20. So this is proportional. So it goes through the origin, And if we multiply the hours, the amount of tests multiplies by the same amount. Oleg ran 8.8 miles in 1 hour and 20 minutes. Assuming he continues at a constant rate, how long will it take him to run any number of miles? So let's see, time and miles. So in 1 hour and 20 minutes, I'm going to convert this all to minutes. There are 60 minutes in 1 hour, so this is 80 minutes to run 8.8 miles. So let's see, that means in 40 minutes he would run half of that, so 4.4 miles. In 20 minutes he would run 2.2 miles. In 10 minutes he would run 1.1 miles. In 160 minutes he would run twice this much. So 8.8 times 2 is 17.6. So this is proportional, because each time you multiply one quantity, you also multiply the other. Uh-oh. I hope this is still working. So each time you multiply one quantity, you also multiply the other. And it goes through the origin, because if you run for 0 minutes, you've run 0 miles. Okay. Number 2. Look at each graph below and write a story or description of what each graph shows. So this is, I notice, speed versus time. So here, the speed is getting faster and faster and faster. So here, the person is speeding up, or getting faster and faster over time. In this one, the person starts off, gets fast, and then stays at a constant speed, because here the speed is not changing. So the person speeds up quickly, then stays at a constant speed. And then this person is speeding up really slow at first, and then starts speeding up faster, and faster. So this one speeds up faster and faster and faster. The two lines at right represent the growing profits of companies A and B. So if company A started out with more profit than company B, determine which line represents each company. So more profit starts off, so at times 0, this would be company A. And then company B starts off with less profit, so this would be company B, because we're starting lower with less profit right there. And how many years will the companies have the same profit? So that's right here. So in 3 years. Approximately what will that profit be? Let's see, they cross right here. So this is 10, 20, 30, 40, 50, 60. So it's thousands of dollars. So $60,000. Which company's profits are growing more quickly? So company B's profits are growing more quickly because their line is steeper. So it has a steeper slope. They're getting more profit per year.